If you've ever had a little look at your LNS chip conveyor nameplate, you might notice there's a Yorkshire rose on it. That's because these chip conveyors are designed and manufactured here in Yorkshire by LNS Turbo UK. We've been invited to go and have a look at their production facility right here in Wombwell, Yorkshire. Let's go take a look. Nathan, thank you so much for inviting us here to come and have a look at your production facility.
You're more than welcome, Rowan, anytime, you know that.
I know, I appreciate it. So there's so much we're going to be looking at in the production house here at LNS. But first of all, we're here in Barnsley. What do you produce here?
Predominantly the conveyors for Europe.
Yeah,
every conveyor that is shipped into Europe is manufactured in this facility.
It's absolutely amazing. We're going to be going through the exact operations that you do here with a full production facility tour. Yep. But as well as the production, there's also a big team in the office just behind us. What do they do?
We manufacture all the conveyors here, but we also import the bar feeders, the air filtration and HPC systems into the UK for distribution in Great Britain.
Absolutely. So as well as supporting the UK, yep. And then producing swarf conveyors for the whole of Europe, and you have exported a little bit around the world as well.
We have, yes. Yeah. Sometimes our conveyors can be sent into America, even though we've got a manufacturing facility in America. Our OEMs we support them, supply conveyors, and then ship them globally.
And this is one of a few production facilities of its kind. Yes. So you mentioned one in America.
We've got one in America. We've got, on the conveyor side, we've got one in Japan and one in China for manufacture of conveyor globally.
And one of them here in Yorkshire, in the UK.
In Yorkshire,
well.
of all places.
Yeah, brilliant. You can probably tell from Nathan's accent, he's one of the locals. How do you do that? How big is the site, and how many people have you got here?
About 56 people in total that work at this site. It's 4,200 square metres in total and 500 square metres of office. The rest is on the manufacturing side.
The rest is all keeping manufacturing in-house, manufactured in the UK, and that's why on the LNS plate you can see that Yorkshire rose.
Yeah, correct.
Which is fantastic to see. Okay, brilliant. What are we going to see? Just tease us, what are we going to see when we go into production and have a tour around?
We'll see the full manufacturing process, from sheet metal coming in, starting at the laser to the press, into welding, into water testing, into pre-assembly, paint, final assembly, and finally the electric department.
Brilliant. Okay, well, we've teased enough. We've spent too much time in the lobby. Come on, lead the way. Where are we going next? Let's go look at production.
Follow me.
Now we're in production. Nathan, before we talk about exactly what's happening here, how do you make a conveyor?
Conveyor predominantly made up from sheet metal steel.
Yeah, absolutely.
That's the core component.
So we'll see all the processes that go into producing a conveyor from LNS. What's process number one?
Process number one, the designers finish the design and send it onto the shop floor, and they send it down to the LVD, and they run a program called Cadman L, which is for the laser patterns, and Cadman B for the press programs.
Yeah, and you can see the laser machine. It's got a huge amount of stock attached to it. What's this?
This is the 10 pallet stacker. In theory, you can run lights out. At the height of our production, we can manufacture 220 conveyors plus. This 10 pallet stacker enables us to run lights out.
Yeah, so you're not waiting for these components, which are the kind of the main component of the conveyor belt. What are we looking at here?
Here is the core components. We've got the incline. The load has been taken across for pressing already. We've got the chutes, the covers, all basically in flat pattern format.
And we're going to see these go and get welded a little bit later. And what are these trolleys for?
These trolleys are ideally to give each conveyor its unique identity. So one trolley contains one full conveyor of sheet metal parts.
And you can produce 220 of these?
Yes.
Every
month.
That's absolutely amazing. Brilliant. You can see how the investment in the raw components of the assembly really helps with that. So we've seen the laser. What happens after laser cutting out a sheet like that?
After the laser, we move across to the presses. We've recently invested in 3 presses now to keep up with the demand.
Yeah, and you've got quite a lot of operators here working these press brakes. And you need a good machine, but you also need a good press brake operator,
Correct.
don't you?
The quality comes from the machines, but predominantly it comes from the operatives that we've got.
Absolutely. So looking at what your colleague here is producing now, checking the angle on this is again, it's another load.
This is another load, you're correct, Rowan? Yeah.
So
he's making sure he's got his angles down to 90 to keep the tolerances that we need.
Absolutely, and every single one of these, once they've been designed, like you say, needs to be unfolded. You need a program producing to actually to bend these properly, don't you?
That program is now, we use the LV Cadman B, which was a thing we implemented last year, and it enables the program to be written inside the office, and then the guys on the shop floor use that program to bend the parts.
Brilliant. So I guess this trolley is almost ready to go.
Correct.
Do we need to take this down? Where do we need to take this down to now?
We take it down to assembly.
Okay, let's go.
Welding.
Brilliant. Oh, a bit heavy these, aren't they?
You need bigger muscles.
So now, Nathan, we've left the trolley here. This has got all the components needed to make a conveyor. What happens next?
The next thing, the welder comes and collects the trolley, brings it onto the tables. We have 10 cells in total. Each cell makes one conveyor. Typically, it's around between 6 and 8 hours.
Yeah, absolutely. And each of these, here we're making a lot of conveyors, but there's also different assemblies you put together as well. What are they?
We do conveyors, we do tanks, we do chip bins, all manufactured here.
And why is it important, do you think, that you guys can supply not just conveyors, but the tanks and put together chip bins as well?
We control the conveyor and tank design. It's easy for us to do a better integration to fit under the customer's machine. We do a lot of conveyors into existing tanks, which is fine. But when we control the conveyor and tank designs, it's a better design process, a better integration for us.
Yeah, and I can imagine you look at the complexity of the assemblies here and the fabrication that needs to be done. These need to be actually really, really accurate components, don't they, once they're put into the full assembly?
Correct. When it's going into an existing machine, we need to make sure that we've used the correct step files, we've taken the correct dimensions to create a design that integrates seamlessly into our customer's machine.
Not only in the design, but in the fabrication as well. These are really skilled operations.
Yes, they
done
are.
by really skilled individuals.
Yeah. Typically, we have a full set of manufacturing drawings, but each cell has a computer inside which they can view the conveyors through a 3D, through an e-drawing software, so they can visually see where all the components go.
Absolutely.
They can range from 60 components a conveyor up to 160 components a conveyor.
Absolutely. You can see you've got 10 welding cells ready. What are these stack lights for?
Green means the cell's in use, blue means they're ready for an operative to come in and that, and when it's orange, it means there's a welder with a problem but can continue. When it's red, that the welder's got a problem and a supervisor needs to go and see what the problem is.
Absolutely, and one of the last processes, one of the last tests, I guess, is once these complex assemblies have been welded together, is making sure that they're leak-proof.
Correct. So we water test all the conveyors, all the tanks we manufacture to make sure that there's no bad welding.
Yeah, absolutely, and that's the first test. But I guess the ultimate test is once it goes on site, whether it fits inside the machine.
That is, yeah, that's part of the service and applications team. We get good feedback now from our existing OEMs. We always try and do a first fit on all our designs.
Yeah, absolutely, and since these are pretty much bespoke per machine model, these are basically crafted with care. And once they've been crafted with care, these beautiful assemblies, I guess we'll go and see what happens next.
We shall.
Let's go and have a look. Cool, so now we see the full complex assemblies put together. I guess is the next thing now to do to paint them?
Before we goes into paint, we actually do a dry fit test. So we put everything that's been fabricated in the welding, we make sure it all fits to the conveyor carcass before paint. So our guys put all the sheet nuts in, put all the covers on, the top cover, mounting covers, the hoods, the bearing covers, to make sure that once we disassemble and it's painted, it goes back together after paint.
It's because they're such complex fabrications, you need to make sure everything fits together.
Make sure we've kept the tolerances right.
Yeah.
Do a dry fit before we actually paint.
And it's proved the tightness of the tolerance and the tight specification you got here. It's amazing that you assemble it, disassemble it, paint it, and then assemble it all over again. That's such attention to detail in production of each one of these conveyors.
Our customers are requiring a lot more quality nowadays than just a conveyor that moves swath. So we have to pay attention to detail, and this is one of the things we do.
So as well as pre-assembly, what happens next?
After pre-assembly and that, it goes into paint, and then after it's been painted, we go into the final assembly, where everything's assembled together, the belts put in, the motor, the sprocket, the drive shaft, the electrics. That is in final assembly.
Brilliant. Let's go see the finished product. So Nathan, here we are, it's the final product. How does it get to this state now?
Once it's been finished in painting and it's been allowed to cure, we bring it into the final assembly area. The belts added, the drive shafts added, the sprockets, the bearings, the motor, the covers are all fitted here in the final assembly. The last point is the electric Invitec control goes on, and then we do a final test for the electric to make sure all the signals and connections are made. And once it's done, the final inspection comes across to inspect it, then it's off to shipping.
That's amazing. This can get shipped anywhere around Europe. It's beautiful seeing the machine come to life when it's all been built here in Yorkshire. Thank you so much for the invitation to come and see how these things are made, Nathan.
More than welcome.